Chapter 18. Data Handling. Data. Statistics is the branch of mathematics which deals with the collection, classification, tabulation and study of data to draw meaningful conclusion from the data. Consider the marks scored in an examination by 20 students. 45, 98, 50, 45, 60, 65, 58, 65, 68, 58, 40, 55, 74, 83, 95, 75, 83, 83, 75, 75. We call it data related to marks obtained by 20 students. The word data means information in the form of numerical figures. A data is a collection of numbers gathered to give some information. Each numerical figure in data is called observation. Raw data. The data obtained in the original form as above is called raw data. From the above data of marks obtained by 20 students, we are not able to draw meaningful conclusion. For example, what are the maximum marks and how many students scored these marks? How many students obtained above 75 marks? How many students obtained below 50 marks? To make the data meaningful and easier to draw conclusions, we have to arrange or organize the data. If we arrange the marks in ascending or descending order, it gives us slightly better picture. Let us arrange raw data in descending order. 98, 95, 83, 83, 83, 75, 75, 75, 74, 68, 65, 65, 60, 58, 58, 55, 50, 45, 45, 40. The raw data, when written in ascending or descending order, is called an arrayed data. Organizing data. When the number of observations is large, then arranging raw data in ascending or descending order becomes a tedious and time-consuming job. To make observation meaningful and easily understandable, we tabulate the data. Marks. Number of students. 1, 2, 1, 1, 2, 1, 2, 1, 1, 3, 3, 1, 1. Total 20. The understanding and analyzing the data becomes easier by means of tables. When the number of observations is very large, to minimize the number of errors and to make tabulation easier, we make use of tally marks. Frequency distribution table. To construct frequency distribution from the given raw data, we use tally marks. We make a table with 3 columns. In the first column, we write variables such as height, weight, marks, etc. in ascending order for convenience. Then, we look at the first observation and put a vertical line called bar in the second column opposite to it. Then, we see the second value, observation, and put a bar opposite to it in the second column. This process is repeated till all the observations in first column are exhausted. If an observation is repeated twice, we put 2 bars, that is, if repeated 3 times, then 3 bars. If repeated 4 times, then 4 bars. To facilitate, for 5 repeated observations, we count the number of bars corresponding to each observation and write in third column, which is of frequency. Let us take examples to understand the process more clearly. Examples. The following marks were obtained by 25 students of class 6 in mathematics: 45, 65, 70, 45, 32, 48, 65, 48, 25, 45, 25, 45, 37, 72, 45, 37, 47, 45, 37, 45, 37, 48, 65, 65, 70. Prepare a frequency distribution table. Solution. We write the marks in ascending order in first column. Marks. Tally marks. Frequency 2, 1, 4, 7, 1, 3, 4, 2, 1. Pictograph. A pictograph represents data through pictures of objects. It is another way of expressing the data representing certain items or objects. The picture visually helps to understand and analyze the data. Example 1. The following pictograph shows the number of absentees in a class of 35 students during the first week of September 2012. Days, number of absentees: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, is equal to 1 absentee. Which day had full attendance? Solution. Against Wednesday there is no picture, that is, no one was absent. Thus, on that day the attendance was full. On which day were the maximum number of students absent? There are 6 pictures against Saturday. Thus, maximum number of students were absent on Saturday. What was the total number of absentees in that week? There are 18 pictures in all, so the total number of absentees in that week was 18. Example 2. The number of desks in rooms of classes 5 to 9 are given below. Class 5, 6, 7, 8, 9. Number of desks 30, 50, 20, 40, 50. Taking the scale, 1 desk is equal to 10 desks. Draw the pictograph and answer the questions given below. Solution. Taking the scale as given, we may draw the pictograph as shown below. Class, number of desks. 1 desk is equal to 10 desks. In classes 6 and 9 there are 50 desks, whereas in other classes number of desks are less. Hence, in class 6 and 9 there are maximum number of desks. In which class there are minimum number of desks? In class 7, number of desks are 2 into 10, which is equal to 20. In other classes, number of desks are more. Therefore, in class 7 there are minimum number of desks. How many desks in all are there in 5 classes? There are 19 into 10, which is equal to 190 desks in all the 5 classes. Bar graph. Bar graph. We have learnt to represent data by pictograph. It is sometimes not only time-consuming, but difficult too. There are alternative methods to represent numerical data. Now we will discuss the representation of numerical data by bars, rectangle of uniform width. Bars of uniform width can be drawn horizontally or vertically with equal spacing between them. The length or height of a bar can be represented by the given number. Such a method is called a bar diagram or bar chart or bar graph. Interpretation of a bar graph. Let us assume that number of computers sold by a distributor during first 6 months of a year was 150, 250, 200, 100, 50 and 200 respectively. This data can be shown by a bar chart as follows. Scale. 1 unit is equal to 50 computers. Observing above bar chart, we can interpret a lot of facts. From the graph, we can say lowest sale of computers was in the month of May as the bar is smallest. The sale during month of March and June was same since the height of bars are equal. The maximum sale was in the month of February as the bar is highest. Let us consider few more examples. Example 1. Read the graph and answer the questions that follow. What is the information given by the bar graph? Solution. The bar graph represents the number of cars sold in 6 cities in 2011. How many cars were sold in Ambala? 4,000 cars were sold in Ambala city. In which city maximum number of cars were sold? In Jaipur, maximum number of cars 6,000 were sold. In which city 2,500 cars were sold? In Meerut city, 2,500 cars were sold. In which city minimum number of cars were sold? In Indore, minimum number of cars were sold. In which city was the sale of cars more than the sale of cars in Allahabad? In Jaipur, sale of cars was more than Allahabad. Construction of bar graphs. We have learnt about reading and interpreting the bar graphs. Now we will learn about the construction of bar graphs. To draw a bar graph, we draw two mutually perpendicular lines. The horizontal line is called x-axis and the vertical line is called y-axis. If the columns, bars are drawn on x-axis, the scale of the heights of the bars is shown along the y-axis or vice versa. The vertical bars are preferred because they give a better look and easy to interpret. The following points should be kept in mind for drawing the bar graphs. The width of the columns, bars, should be same throughout. The space gap between the bars should be uniform throughout. Choose a suitable scale for determining the height of the bars. Labels written along the horizontal axis can also be written inside the bars or at the top of the bars. In order that the bar graph look attractive, its bars can be colored or shaded. Example 1. The marks obtained out of 100 in each subject by Tarun are given below. Marks, subjects. Draw a bar chart for above data and answer the questions given below. In which subject maximum marks are obtained? Solution. Bar chart. Scale. 1 unit is equal to 10 marks. Marks in examination. Subjects. Maximum marks are obtained in mathematics. In which subject Tarun has to improve a lot? Tarun has to improve a lot in English. Maximum marks 85, minimum marks 38. Difference 85 minus 38 is equal to 47. Difference between maximum and minimum marks is 47. Note, the difference between maximum and minimum value of observations is called range of the data.